Hi everyone, welcome to lesson 2 today. Today we're going to be talking about reflections and stretches, and this is still part of our transformation unit. In our notes here, we're starting off with an opener. It's going to refresh you on mapping, and it's going to talk about H and K. Reminder, H and K only affect horizontal and vertical translations, aka you moving things left, right, or up, down. So again, H is going to move things left, right. K is going to move things up and down. You can figure out the opener on your own, and I will come back to that at a later time. But for now, I'm going to get right into our notes. So today's lesson is we're going to start off with reflection. So reflection is going to create a mirror image first off. So we always have our original versus our image, which is our new image. We reflect it over a line of reflection, and you have two scenarios for reflection. The first one here is when you have original xy and your image point becomes x comma negative y. What happens here is basically you have a negative in front of your function. This means that we're reflecting it over the x-axis. So that's key here, and I'm going to try my best to highlight that there. So whenever you have a negative in front of your function, you are reflecting over your x-axis. Down here, we're going to talk about xy and what happens when our x's become negative. So we changing our x's. Here, our negative sign, our reflection symbol, is going to be within the brackets. So here we are reflecting it over just the y-axis. So make sure that you know which axis you're reflecting over. By the way, if you're reflecting over the x-axis, this is what we sometimes refer to as a vertical reflection. REFL is short for reflection. Here, if you're flipping it over the y-axis, aka the line that goes up and down with the y-axis, this is what we call a horizontal reflection. Again, the big takeaway here from this first two bullet points is what's our original and what's the mapping that's going to take place on our image coordinates. Getting right into example 1 here. So here is a graph that's given to you. This is just a randomly drawn graph. It's given to you here. You have a table of values that correspond to it as well. So for at -4, you're at -3, -2, you're at -3, at 1, you're at 0, and 3, 4, 5, -4. So those, all the points are connected. That makes our weirdly looking graph. So the question right now is what happens to this original graph if we are reflecting it with this function here, y equals negative f of x. So first off here, we got to figure out, well, are we vertically reflecting it or horizontally reflecting it? Anytime that you see a negative on the outside of your function, we are a vertical reflection. So vertical reflection. So over here, definitely this means that we're going to be doing a horizontal reflection. Okay. So to do a vertical reflection, all you have to do is you're going to switch around all your y values. So again, mapping wise, if you had x comma y, and then you have a vertical reflection, that means you have x comma negative y. And when I mean switch around all your y's, I mean just switch signs. Over here, for a horizontal reflection, the mapping would be original x comma y. New would be negative x comma y. So all our x's would just have a change in sign. So I'm going to copy down all my x values here because my new function, the x values did not change. So we have -4, -2, 1, 3, and 5. My y values all change. So my original y value is -3. So it's going to become +3. Here it's going to become +3 as well. 0 is just going to remain 0. It was a +4, so now this one becomes -4, and -4 becomes +4. So going back to my first graph here, I'm just going to replot everything. So again, originally my y values here on these two were negative. If I count 3 away, lining it up, it's going to be 3 positive, and right there as well. Here, this one here did not change, so I'm just going to double up on that coordinate. Here it was already positive, so if we switch it, it's going to, or reflect it over our x-axis, we're going to have a negative value. This looks to be at negative 1, 2, 3, 4. So I'm going down 1, 2, 3, 4. Just counting it out just to be extra careful. Here, our original graph was at negative 4, so now this one here will be at positive 4. So I have my dots. I'm going to try my best to connect my dots, and here we go. This is what it should kind of look like. So went straight across. And there we have it. There's our vertically reflected graph, aka the graph where you're reflecting it over your x-axis. And here's what it's going to look like. Horizontal reflection, reflecting it over your y-axis, over this guy here. This is your y-axis, by the way. So y and x-axis right here. So taking our original and reflecting everything over our y-axis. So again, you could start off with your coordinates. That's what I would do, or you could just sketch it on and then copy down your coordinates there. It doesn't matter. So what's going to happen here? So all my original y values stayed the same. So I'm going to have negative 3, negative 3, 0, 4, and negative 4. But all my x values, they change. Originally it was negative 4, so now this is going to become positive 4, positive 2, negative 1, negative 3, and negative 5 respectively. All I have to do now is graph this on. So I need to find where 4, negative 3 is. So at 1, 2, 3, 4, 4, negative 3, we are all the way down here. That's going to be my first dot. At 2, I'm also at negative 3. At negative 1, I'm at 0. At negative 3, I'm at positive 4. And at, where's our last coordinate? It should have been negative 5 there. Negative 5, we're looking at negative 4, which is 1, 2, 3, 4, right down here. And again, I'm going to try my best to connect my dots, and it should end up looking like the following. So it's basically take this graph and you just flipped it over your y-axis to get to this here. There's a quick side note here. It says, note that the transform graphs are congruent to the graph of y equals f of x, meaning they're the exact same graph. The shape and size should not change, just the positioning of everything should change. So let's talk about invariant points. So what is it? An invariant point is or are points on the graph that have not changed after a given transformation. So if you go back, let's take a look at our original versus our first graph, the blue. Do we have any coordinates that double up? Yes, right here. These doubled up at 1, 0, it doubled up right there. So what can we say? There's an invariant point between the original and a vertical reflection. Let's take a look at the original versus our horizontal reflection here in red. Do we have any dots that match up? Yes, we do, right here. Even though that wasn't a coordinate that was like found on our table of values, it still matches up. This is still the same coordinate on both graphs. That's 0, negative 1 there. So what are the invariant points on the previous two graphs compared to f of x? So our invariant point for the first one here, that both doubled up, so we're flipping it on our x-axis, we doubled up on 1, 0. When we flipped it over our y-axis, the point or coordinate that we doubled up on, or it's the same that didn't change, was 0, negative 1. So these are our invariant points. It says point or points, meaning that sometimes you could have multiple invariant points for sure. Here it says, what's the significance of the location? So the key here that you need to know is when you're reflecting it on your x-axis, so I'm just going to write it down here, reflect on x-axis. So when you have this scenario reflecting on the x-axis, your invariant points will be all the points on your x-axis. So reflect on x-axis, invariant points are all invariant. So your invariant points are found on your x-axis. And then over here, if we are reflecting it on our y-axis, so again, here's the scenario, reflects on y-axis. Where are we going to find all our invariant points? So all the invariant points will be found on the y-axis. So invariant points here, invariant points found on y-axis. All right, so that's what an invariant point is. Again, it's a point that did not change regardless of whatever transformation occurred. Here's our two examples, and here's where you'd find them. If you're reflecting on the x-axis, if you're on the x-axis originally, you're not going to move. And if you're reflecting on the y-axis, if you're on the y-axis, it's not going to move either. In example 2 here, we have the equation of the image. So basically what's going to happen in this example here. So if we had y equals 10x and you're reflecting it on the y-axis, what's going to change? So again, a reminder that if you're reflecting on the y-axis, that's a horizontal reflection. So I'm looking for something similar to this. So if we had y equals f of x, that's my original. My new is going to be y equals f of negative x. So wherever there's an x in my function, I'm going to have a little negative sign beside it. So here's my original, y equals 10x. And here's my transformation, or my reflection. It's going to change this equation so it says y equals 10. And that negative has to be beside x, so I'm going to shove in a little negative x right there. So that negative sign is an exponent with x there. In this one here, if you have a radical and you're reflecting it on the x-axis this time, so what's going to happen? So again, let's just jot down some quick notes. Here's my originals. So if I had a function originally, that's what it's going to look like. If I'm reflecting it on the x-axis, it's going to end up looking like y equals negative of that function, whatever that function was. So in this example here, we have y equals square root x, and if I'm reflecting it on my x-axis, this is now going to become y equals, and let's add in our little negative to denote reflection, it would be negative square root of x. There we go. So the negatives just kind of tell you where you're reflecting it, either on the x-axis or the x-axis down here or the y-axis up here. Again, on the y-axis, the negative has to be in the function right beside x, whereas on the x-axis, it's outside of the function in front of it.